probability of multiple events using tables. So in this example, a 6-sided die is tossed twice. List the sample space. Now, we've got to discuss a couple of concepts here. The questions will usually suggest that you use a table, and you are looking for, on the rows of your table, the first event, all its possible outcomes. So the first event is the first toss. And my outcomes for the first toss are 1, 2, 3, 4, 5, or 6. Oh, I'm sorry. Here we go. So the rows, label the row here with the first option of the event that happens first, and the columns get labelled, this is the second toss, and their outcomes go here. The options that we could get rolling a die are 1, 2, 3, 4, 5, 6. So it's the first die and the second die and the different outcomes that we could get in each case. Because it is possible that on the first dice you get a 1, and on the second dice, or die technically, you get a 1, and the result or the outcome is 1, 1. With dice, sometimes they'll ask you, they'll say, and the sum of the upward faces is recorded, and then you'd add those together in this table and say the sum was 2. If they just ask for the sample space when you're tossing 2 dice, assume we want to see what was on the faces. So I could have tossed a 1 on the first dice and a 2 on the second die. That would be 1, 2. Now, yep, it's a little bit tedious to fill these in, but you do just kind of have to put up with it. So a 1 on the first die, and I could have got any of the other options there. So that's a total of 6 outcomes there that we've got as a possibility. Sorry, that's a little bit hard to read. So I could have got a 2 on the second die and a 1 on the first. So you can see, yes, I know, it's really boring to fill it in. And etc. You really would fill the whole thing in, and that is your sample space of these 2 events happening at once, or one after the other, it doesn't really matter. Now, yes, I would complete this, but honestly, there's a question in the textbook where you've got to do it. Do this once, so you've done it, and then you won't have to do it again in the textbook questions. Now, if I have to list the sample space that's there, to state the number of outcomes, we've got the number of outcomes that are possible on the first one, multiplied by the number of outcomes that are possible on the second one. So that would be 6 times 6 equals 36 possible outcomes when you toss 2 dice. Notice that they can get the same sum. So this adds up to 3, and so does this one. But this is 2, 1, and this is 1, 2. So they are different outcomes, but they would both add up to 3. Now, in order to actually solve these questions, I will need to have that table in front of me, and I don't want to waste your video time by creating the table. So I'm just going to very quietly refer to this one, for which I apologise. And we'll check that you can read that one. So the probability of getting a double, it's quite useful. The doubles go down this leading diagonal here, so that's 6 out of 36, which will of course be 1/6. The probability of getting a sum greater than or equal to 10, the sums move in a pattern across this way, so it adds to 2, adds to 3, adds to 4, adds to 5. So you find your set where they add up to 10, 1, 2, 3, 4, 5, 6. Again, greater than or equal to 10, there's 6 possible outcomes out of the 36. And the probability that you've got a sum that does not equal 7. Now you've got, of course, the option of working out how many add up to 7, 1, 2, 3, 4, 5, 6, and using the complement of 7. So we'll get those 3 probabilities written in. This is 6 out of 36, which is 1/6. That was also 6 out of 36, which was 1/6. And this one, sorry about squeezing it in, I would say that equals 1 minus the probability of a 7. Oh, it's a little space, sorry. Which is 1 minus, and what did I have? I had 1/6. So that's 5/6. The last question, find the probability of a sum of 12 given that the sum is at least 10. So at least 10 means 10 or greater, so we've just looked at that. Going back to here. So the total of that we're taking this conditional probability out of is 1, 2, 3, 4, 5, 6 outcomes where the sum is 10 or more, and the outcomes of a sum of 12 is 1. So for conditional probability, this is question D, the probability of 12 given 10 is going to be the number of outcomes that gives me 12 over the number that gives me 10, which was 1 out of 6. We've got lots of 1 out of 6 here. And we've gone a little crooked there. Now, that is one way of looking at the tables. And a little bit messy here. 2 letters are selected from the last 4 Scrabble tiles, and I've said no replacement. A lot of the questions will be without replacement or with replacement. It's a different option if you're saying, look, I take a letter, I look at it, I put it back, and then I take another letter. Or, as you would in Scrabble, you take a letter and then you take another letter, because you get to take and keep 2 letters. You don't put them back in between. So the question of whether this will be with replacement or without replacement has to happen every time we're looking at a probability scenario with multiple events. Often it will say, for something like a dice or a coin, the question of replacement doesn't come up. It's done without replacement. Sorry, it's done with replacement, my bad, effectively, because the first dice is the same as the second dice. It doesn't change, getting a 2 here doesn't erase the 2 on your second die. So they'll want a table for this. So your first letter could be Q, A, E, or E. And I didn't leave enough space. Your second letter could be Q, A, E, or E. But if you choose a Q on the first letter, you can't choose a Q on the second. You could get QA, QE, or QE, but you can't get QQ. I could get A and Q, but I can't get A and A. So notice how this leading diagonal, when there's no replacement, gets crossed out. I could get AE or AE. Here, EQ, EA. I can't get EE on this one, but I can get EE there because there's got 2 different E's. EQ, EA, EA, and nothing. Now these don't count as outcomes because they can't happen. So the total number of outcomes here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can't do 4 times 4. What you can do is say, look, there's 4 letters for my first choice, 3 letters only remaining for my second choice, so the number of outcomes is 4 times 3, which is 12. So the probability of getting the outcome QE, probability of QE, they've given to me in order, so I just want Q then E, that's 2 out of my 12, which is 1/6. Selecting 2 E's, there's the only way that can happen. So probability of EE is 1 out of 12. Probability of selecting 2 vowels, nothing with a Q. So it's 1, 2, 3, 4, 5, 6. an E and a Q. So either of those are fine and either of those are fine. Intersection will be fine there too. Lost count, 1, 2, 3, 4, 4 over 12, 1/3. And the last one's conditional as well, selecting 2 E's given that at least 1 E is selected. So you're only taking this out of the options where there are E's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probability of 2 E's given 1 E is 1 out of, what did I say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry about that. So you need to think about your table as, is there a placement or is there not? You need to set up your table with the first thing that happens and the second thing that happens and list the outcomes that are available to you. And you need to be careful as to whether you're taking, for example, using the language and or. So if I'd asked here the probability of getting an E and a Q, you're using the intersection. But if I'd asked for the probability of E or Q, you're using the union, and that is anything with an E or a Q is going to be fine. And that's like everything. There's nothing there that doesn't have an E or a Q, so it's 1. So be careful with the language and or, and use the appropriate notation is always a good idea.